Hi, I'm Rob Carter at Piezo.com. I'm a principal engineer here, and I'd like to thank all of you for your wonderful response to our video on the Piezo Flow fan. And I am here to answer some of those wonderful questions that you gave us regarding the fan. So let's get into it. Well, before we get to the questions, I'll give you a quick background. This is the original fan that was in the video. It's been running for 6 years, actually more, without stopping 24/7. It's still intact, it still works. And Mayday developed this for a customer, and its purpose was to reduce the size of a passive heatsink by adding a slight active element, the flapping fan, which did not impact the lifetime of the device. So with that much background, let's get on with the questions. All right, regarding moving parts, in the original video we said there were no moving parts. That is incorrect. There is a moving part. What is correct is that moving part has no wearing surfaces whatsoever. And it has mere vibration. It's all within elastic limits, and in theory would go on as long as the aluminum in this heatsink. So let's talk about material fatigue. No one is worried about the little flexing elements on the end. Everybody's concerned about the piezo ceramic. The piezo ceramic in this fan is run well under its elastic limit, well under its fatigue limit, and has already been proven multiple times to run for billions and billions of cycles without any sign of degradation of amplitude or breakage. Power draw. This is a capacitor, pure and simple. It does a little bit of work on the environment, and it takes precious little energy. This fan that you're looking at draws only between 100 and 200 milliwatts, depending on what the air loading is in front of it. And that's pretty much the whole story. Operating the fan in hazardous, polluted, or dirty air, that's an easy one. The piezo ceramic is hermetically sealed in an encapsulant and has zero contact with the atmosphere that it is moving. Many of you have noticed on our website this is a very expensive part. There's a reason for that, and you've heard of the reason. It's called economy of scale. To date, there has not been a large volume application for this fan, but it can be produced in large volume at a very reasonable cost. So we are still looking for that application. A lot of you have said in your responses, well, this fan has been around for so long, why don't we see it replacing fans everywhere? And the answer is, this fan doesn't have an inlet and an outlet like most rotary fans do, where they draw air in one end and push it out the other. It creates a convection-like flow. And it works best in open air, and the more you constrict it with inlets and outlets, the less it flows. So it does a lot of air motion, but it is very difficult to replace a fan that has a back pressure, an inlet, and an outlet. And that's why you don't really see it replacing everything. So what are some of the applications where this fan has a very significant advantage over a traditional magnetic fan, aside from wear and tear? One is self-aspirating sensors. Might be a thermostat, might be a gas detector, might be a dust detector. This fan runs on such small power, it can be battery operated, and it can go right inside a cabinet, where a small size cabinet where a sensor lies, and it can actually move air over the sensor. it gets around the time delay that comes with diffusion of the detected particle or gas that normally occurs, and it has a long life. So that's one. All right, so a second application would be destratification of air in a sealed electronics cabinet. Now, typically in a small cabinet, sometimes it's a real advantage not to have any vents to the outside world for various reasons. And in that case, you might have maybe 30 watts in a small cabinet, maybe 3 times the size of this. That's the approximate volume. There's a hot spot. Usually some power dissipating thing, might be the microprocessor, but it might be a piece of power electronics. So this can be, you can avoid all complications from that heat being piling up in there with no air circulation by just putting one fan in and moving the air around inside. They call it destratifying, so it doesn't get stacked up static. That's a great application. It's already been done many times over during the long history of the fan. Another application is artificial convection in space station environments. When air has to be used in space stations because there's people there. And because there's air and no gravity, anything that gets hot, it doesn't matter if it's electronics or it's a refrigeration system or air conditioning, anything that gets hot has no way to convect air because there is no gravity. Air does not move away from the hot objects like it does on a typical heat sink that's used earth. So these fans can actually be used to create an artificial convection, a directed flow, and it works really, really well. Another more obscure application is use in temperature control chambers. This is not obvious, but we all know that you can control the temperature in a chamber by turning heat on and off, and we have servo systems for doing. You have a thermostat. The thermostat turns the heat on when you need the heat, and then it turns it off. What happens when you turn the heat off? It takes a long time for it to dissipate. So this fan has a very short startup time. It's milliseconds before the air is blowing, and there's just no rotary fan that can do that, particularly a low power one. So it's been used for very, very tight temperature control on the outside of laser systems, for instance, where you have to have the surface of a long tube kept at a constant temperature. And that's a great application and to come. By far the most popular question was, what kind of sound does that fan make? You know, they didn't put any sound from the fan. So I thought that this is going to settle that question altogether. Here is the original fan. I am going to plug it in, and you can hear what kind of noise it makes. You may or may not hear it already, but this is the same microphone system that I've been talking on. And the fan is 12 inches from the mic. Well, thanks again for your wonderful questions about the piezo fan. And if you'd like more information, check out our blog at blog.piezo.com. And if you'd like to be notified about future videos, you can just subscribe to our channel.